Good morning, everyone. At this point of class, hopefully everyone passed their homework up from yesterday. Just a reminder that that will be graded for accuracy. So if you did not turn it in, you may turn it in tomorrow for half credit. Today's objective is to apply function notation to problems. So I need everyone to open up their purple Chapter 5 note packet to page 13. So again, I need everyone to open up their Chapter 5 purple note packet to page 13. Okay, we are going to talk about function notation. So before I start to describe what that is, I'd like to do a little review of what a function is and how we know whether something is a function or not. Okay, so at the very top of page 13 of your notes, I just want to fill in part of this with you. The first thing that I'd like you to write down is the definition of a function. If Ms. Wingrove and I were here today, we would have asked you, what is the definition? So hopefully you remember that that a function, for every x value, there is exactly one y value. We have also said that it is 1-to-1. So you should be writing down, for every x value, there is exactly one y value. And hopefully you remember these are the problems that we would write in a table and look to make sure that if any of the x values repeated, if they went to a different y value, it was not a function. If any of the x values repeated and they went to the same y value, it was a function. One more thing that I'd like you to write down is that we used already this year the vertical line test to determine if a graph is a function or not. So you're just going to fill in there, vertical line test. And this was where we took our graph, we would draw a vertical line through each of them. If the vertical line touched the graph more than once, it was not a function. If it touched it once, then it was a function. The 6 types of functions that are underneath, we are not going to worry about today. So I want you to skip down to the middle of your notes where it says function notation. Here's what is extremely important for today. So where it says, I'm going to move this over, well maybe not, where it says function notation, I want you to write next to that, equations are written such that f of x. So here's what's really important. The f and then the parenthesis with the x in it, that is function notation. So in orange, I want you to put in parentheses on your notes in the same spot. You read that as the function of x or f of x. And then the second part is it replaces the y value. So f of x, which is the f with the parentheses and the x in it, is another way to write y equals something. In other words, f of x, I want you to write this down, is the exact same thing as y. It's function notation. It's just another way to write y equals something. So if we had an equation, and let's say it's y equals 2x minus 1, which you know really well now that is slope-intercept form, if we were to rewrite that using function notation, you would write it as f of x equals 2x minus 1. F of x is the exact same thing as y. So I want you to make sure that you remember and understand that right now. Why do we need this? You're probably sitting there right now wondering, well, why do I need to know that if it's the same thing as y? The main reason in Algebra 1 that you use this is so that when you are plugging x values into a function, you use the f of x notation, and we're going to put the number in these parentheses here. So let's say we need to evaluate or solve this function. when x is 2, which we're going to do today in a couple minutes. You put the 2 into the parentheses and you solve. It's a lot easier to do that than write out an equation in y equals form and then say solve when x equals 3, or to write all of that out. So again, in Algebra 1, we are using function notation to make it easier to find values of x. Okay, the second bullet point that you need to fill in is it says it does not mean f times x. You've learned so much in pre-algebra, even in this course, that when you see parentheses and something in front of it or next to it, it means multiply. Function notation does not mean that. F of x is the same thing as y, and you'll hear Miss Wingrove and I keep saying that. Okay, and then the second to last thing here is you can use any other letter. Of course, the book is going to try to confuse you. Function notation does not always have to be f of x. You could have h of x, you could have g of x, we could use the entire alphabet. Any of that is the exact same thing as function notation. Last part is we are always going to write our answer as an ordered pair. Always, 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 and I know you're really good at this, but if you need to, remember your ordered pair is always x, comma, y. So we're always going to write our answer as an ordered pair. Okay, we're going to do a couple examples. So right underneath where it says function notation, what I just explained, if it does not make sense, I think that this will help you. So what you have for the first example is you have the same problem written twice. There's a reason for this. I want to do this once with you when it's in y equals form, which is over here. And then we're going to do it again using function notation, so that hopefully that really helps you to see the difference if you have not seen it yet. So the first example asks us here to find the value of y equals 2x plus 5 when x equals 4. So you know this from pre-algebra. We did this a little bit this year as well. You're going to take x equals 4. I want you to draw an arrow, and you need to plug it in or substitute 4 in for x and solve for y. So again, you've done this before, so let's do that. We have y equals 2 times 4 plus 5. Order of operations tells you to multiply first. 2 times 4 is 8. Rewrite your plus 5. 8 plus 5 is 13. So we found that y is 13 when x is 4. You're done, but you need to make sure that you write your answer as an ordered pair. So x is 4, y is 13. If you'd like to check your answer, take your x and your y value. If you plug them back in and solve, you end up with 13 equals 13, which is true. So you know you did that right. Okay, so that's the way you're used to doing it. Let's do the same example using function notation. So now we need to find the value of f of x equals 2x plus 5. Here's the notation. Remember, f of x is the same thing as y. The whole thing is the same thing as y. This number 4 that is inside the parenthesis, that is what you are taking out and plugging or substituting in for x. So if you draw an arrow, maybe circle the 4, draw an arrow, you're putting that in for x. The f of 4 means you are evaluating the function when x is 4. You are still solving for y. So we have f of 4 equals 2 times 4 plus 5. I'm just going to start writing equals now. 2 times 4 is 8. Rewrite your plus 5. And then 8 plus 5 is 13. So the function evaluated at 4 is equal to 13. So I want you to do this. The number inside of parentheses is always x. What f of x is equal to is always y. Remember, f of x is the same thing as y. So take your x and y value, write them as an ordered pair. That's the answer, which of course is the same as the answer we got on the previous problem. They're the exact same. We just did the second one using function form or function notation. Okay, if you have any questions on that, please pause the video and Mrs. Ankeny will explain further. Let's do one more together. Let's take a look underneath there at example 1. Okay, example 1. So we now need to evaluate the linear function when x equals -3. So they tell us here what x is, but typically you will see function notation written as f of -3 equals 2x plus 12. So we need to evaluate the function when x equals -3. I want you to put a little x underneath -3. Don't forget, that is the x value. Circle or underline or just draw an arrow. We are solving for y when x is -3. So we have f of -3 equals 2 times -3 plus 12. Order of operations tells us multiply first. So we have -6 plus 12, which hopefully you're all saying or you know that that is 6. We just found that f of -3 is equal to 6. So we evaluated the function when x is -3. We found f of x, which is the same thing as y, is 6. So write your answer as an ordered pair. Your ordered pair is -3, 6. Okay, I'm going to move on to the different examples. If you feel like you need another practice problem here, pause the video and Mrs. Ankeny will go over either 2, 3, or 4 with you. You still have 3 other examples here, but you do the exact same process for every single one. Okay, so when you're ready, I'd like you to flip your notes to page 15 so I can show you the other type of examples using function notation. And don't worry about what I'm skipping. Okay, so on page 15, the directions now say that we need to find the x value of a function. So we need to find the value of x so that the function has the given value. So if you look here, we now have, here's our function, and then they tell us instead of x equals something, they tell us what f of x equals. So I want someone to tell us f of x is the same thing as what? Okay, hopefully you said y. Since f of x is the same thing as y, we need to take this 3 and we need to plug or substitute it in for f of x. I want you to circle 3, draw an arrow just like I did, scratch off the f of x. You are replacing the entire f of x with 3. I know we saw a lot of mistakes last year with students trying to put the 3 in the parentheses. Do not do that. The 3 has to go in for the entire f of x because that's your y value. You have to find x. We have 3 equals 6x plus 9. So that 3 goes in. You're now solving an equation. This one's going to be a 2-step. So when we go to solve for x, what is the first thing that you need to do? Okay, hopefully you guys said subtract 9 on both sides. We want to get all the numbers on one side and the x on one side. 9 minus 9 is 0. 3 minus 9 is -6. So we have -6 equals 6x. Divide everything by 6. We have x equals -1. Using symmetric co, make sure you flip it around. So you just found x this time, not f of x. We already were given that y is 3. Remember, f of x and y are the exact same thing. So I want you to put a y underneath what you were given. And we need to write our answer as an ordered pair. So -1, 3 is the answer to this problem. And that was with you finding x. If there are any questions on this one, please pause the video. Mrs. Ankeny will explain further. Okay, let's do one more together. Let's look at number 2. Okay, number 2, we have a function, and here's a function where it's not f of x, we have h of x equals 2x minus 10. And we need to find x, so they gave us that h of x, and don't forget, function notation is the same thing as y, is equal to 6. I want you to circle the 6. We are plugging that in for the entire h of x. Cross off h of x, and I want you to scratch it out until you get really good at these. If they give you what h of x equals, that goes in for the entire function notation. So we have 6 equals 2x minus 10. So it's like we're plugging y in, we are solving for x. Solve our two-step equation. I'm sure you guys are ahead of me at this point, if you haven't been already. Add 10 to both sides. So we have 16 equals 2x. Divide both sides by 2. We have x equals 8. Use symmetric co. Flip it around. You found x equals 8, which is correct. So we need to write our answer as an ordered pair. So we have x comma y. We have 8 comma. Don't forget h of x is y. They gave us the y value. So 8 comma 6 is the answer, and always write your answer as an ordered pair. Okay, if you have questions, pause the video. If you would like a little bit more practice, there are examples 3 and 4 on here. Mrs. Ankeny will go over them with you if you need additional practice. Excuse me. Okay, if not, if you guys are okay, I would like to explain your homework to you. So I need everyone to open up their homework packet to page 18. And that's your gold packet, so I'll wait until you're there. So page 18, at the top it should say practice 4.7b. Okay, so when you're there, I'd like you to take a look at it. You are going to need another piece of paper for this. Do not get up yet, but in a minute you can. You're going to do all of them. Please make sure that you write your answer as an ordered pair. Okay, please make sure you're careful with the directions. If they give you x, you need to find f of x, which is y. If they give you the f of x value, then you need to plug that in for f of x and find what x is. So what I need you to do first is, where it says evaluate, the very top direction, you need to evaluate when x equals -3, 0, and 2. I want you to cross off the 0. Do not worry about that. So the first part of the directions, just evaluate the function when x equals -3 and when x equals 2. So for 1 through 12, you're going to have 2 answers for each of them. Shouldn't take long. Write your answers as an ordered pair. The second part, I just realized number 13 through 22. The book made a mistake on this. So let me show you 13. Do you see how after 13 they have the colon and it just is 18? What they should have done here, and I want you to do this for all of these, that number should be f of x equals 18. So for 13 through 22, the number after the semicolon is what f of x equals. So cross that number off and write it as f of x equals whatever it is. For those, you only will have one answer for 13 through 22. And again, please write it as an ordered pair. Okay, so that is it. Please make sure you have your homework done for tomorrow. If you have any questions, ask Mrs. Ankeny today or come in during homeroom.